All right, ladies and gentlemen, so now we're going to be moving into how do I do operations with numbers in scientific notation. Remember that this is the correct form for scientific notation. You have a number up front that's between 1 and 10, can't be more than 10 though, or equal to 10, times, and then a power of 10, so 10 with an exponent. We're going to actually be splitting this video into two parts. So this is going to be part 1. And usually we would do adding and subtracting first, but we're actually going to do multiplying or dividing first. So the world population is about 7 billion. There are 4.6 times 10 to the 7 ants for every human on the planet. That's a lot. How many ants are there in the world? So the first thing I want to do is I want to take this 7 billion, which is 7 with 9 zeros, and I want to write that in scientific notation. So that means I have to take my my decimal point from the end and put it in the beginning. So 7 times 10 to the 9th. All right, now I'm going to multiply that, and I'm just going to put this number up front because I didn't leave myself enough room, times 10 to the 7. Well, this is where we're going to follow now our rules that we practiced earlier in the chapter on multiplying numbers with exponents. So I can multiply these two numbers out front. Right? The only difference is that now we actually have the times symbol in here. So I'm going to multiply those, which is 32.2. I did that on a calculator, I will fully admit that. And then I have the same base, so when I'm multiplying, I add the exponents. The thing is that now I have to make sure that I have this in correct scientific notation, because this right now is too big. So I have to move my decimal over one more place, 3.22, which adds something to power of 10, because I moved 1 point over. So there are 3.22 times 10 to the 17 ants in the world. That's a lot. All right, let's try another one. The mass of the moon is approximately 7.3 times 10 to the 22nd kilograms. It would take approximately 26 million moons to equal the mass of the sun, determine the mass of the sun. All right, so again, I'm going to take this 26 million and write it in scientific notation. So that's 2.6 times 10 to the 1, 2, 3, 4, 5, 6, 7. And now we're going to multiply. So 7.3 times 10 to the 22nd times 2.6 times 10 to the 7th. So just like we did with our rules for exponents, I'm going to multiply the numbers out front, which gives me 18.98. I am going to add my exponents for the power of 10. So 22 plus 7 is 29. Or, oh my gosh, I said 29 and I still wrote 7. Sorry guys, 29. So now I have to make sure this is too big, so I have to move my decimal point 1 over, 1.898, which then increases this from 29 to 30. So it's putting together scientific notation, and it's putting together what we did with our rules for exponents. All right, number 3. The speed of light is 300 million meters per second. The sun is approximately 1.5 times 10 to the 11th meters. How many seconds does it take? So this is actually going to be a dividing problem. So again, I'm going to take my 300 million and I'm going to put it in scientific notation. 3 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. And now, so I want to know how long it's going to take. This is a division. So I'm going to do 1.5 times 10 to the 11th divided by 3 times 10 to the 8th. All right, well, we're really then breaking it up. I can take and divide that part, which is going to give me 0.5. Again, I did that on a calculator. Now, when I am dividing, I subtract my exponent, so times 10 to the 3rd. This, again, is not in scientific notation, so we're going to have to take, and now we have to move it one place to the right, which will decrease my exponent. So 5 times 10 to the 2nd, and this was a word problem, I should say seconds. I should say ants, sorry. Okay, over here, a certain social media company processes about 990 billion likes per year. If the company has approximately 8.9 times 10 to the 8th users of the social media, about how many likes is that per person? So excuse me, so we're going to take our 990 billion, which is a really big number, and I'm going to write that in scientific notation. 9.9 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11th power, because remember, we're not just counting zeros. I'm going to take that and divide it by how many users they have, because I want to know how many likes are there per user. Okay, so when I divide this out, you're actually going to get a pretty big decimal, so I'm going to round this. So again, we're working on this part first. I'm going to divide it. It turns out to be approximately 1.1. Again, approximately. Up here, I'm going to take and subtract my exponents. 1.1 times 10 to the third. This up here, though, says write your answer in scientific notation and standard form. So here it is in scientific notation. Standard form, the 3 tells me to go 3 places. So there are about 1,100 likes per user. All right, if you turn the page, this is really going to end up being our part 2, but there's rules at the bottom. So I want to fill in the rules for multiplying and dividing. So for multiplying, you're going to multiply the coefficients, which I'm going to abbreviate because there's not a lot of room here. You're going to add the exponents, and then you're going to simplify, meaning make sure that it's in correct form. So I'm going to put that down here, correct form. For dividing, we divide the coefficients. We subtract the exponents, and then we simplify, and again, that means making sure that it is in correct scientific notation. So I'm just going to draw a little arrow here so that you know what goes in those spots. All right, so we're going to save the adding and subtracting for tomorrow, so that's why, again, we're going to take this part and break it up into 2 days. But any questions? I know this is new stuff, it's different, but any questions, bring them to class. Have a nice night, guys.